write the chain rule. And the chain rule is we're taking the derivative of a composite function. And if you recall, a composite function is a function inside a function. For those of you that had Mr. Karsh, which I think is all, yeah, he would say fog and goth, and then he laughs because that's his idea of a joke. Never funny to me. I just nod my head and smile. Okay?
It's funcception.
Okay, so to take this derivative, we keep f just like, we take the derivative of f, keep g of x as it is, and then multiply by the derivative of g. That's the chain rule. That's what you guys are doing. Notice when we go back and we find this antiderivative, this g prime isn't there, is it? Because it was caused by taking the derivative. It's not in the original function. Everybody okay with that?
I think so.
Alrighty. So remember the chain rule, we have something similar when we're taking antiderivatives. It is called U substitution. Look at the integrand. Think about taking the derivative. If the derivative requires the chain rule, then the antiderivative will require U substitution. So, what I do is I always look for some grouping. So parentheses is grouping 3 minus 4 together, right? If you remember PEMDAS, sometimes it's called, parentheses have the higher order, and it means you do whatever in parentheses first. Parentheses is grouping. Square root is grouping. Fractions are grouping. I'm going to talk about all of those, okay? And if you take a look, I have this inside a set of parentheses. So what I'm going to do is I'm going to say that U is equal to 3x minus 4. What's inside those parentheses? I'm going to get rid of 3x minus 4, and I'm going to replace it with U. Now, so I'm going to put this whole integral in terms of U. That means I have to find something to replace the dx with because it's not in terms of U. I have to find out what dx is equal to in terms of U. How do I do that? I take the derivative. So the derivative on this side is going to become du dx. And over here, if I take the derivative, I get 3. Now what I'm going to do is multiply both sides by dx, and I get du is equal to 3 times dx. I want to get dx by itself, so I have 1/3 du equals dx. So this is what dx is in terms of u. So now I'm going to rewrite this. This 3x minus 4 will become u, because I said anytime I see a 3x minus 4, replace it with a u, it's going to be to the 1/5 power.
You mean to the 5th power?
To the 5 power, the 5th power. I think I said 1/5. That was wrong on my part. Times, I'm going to replace dx with 1/3 du. This is a constant, and in the properties of integrals, I can bring it out front, so I do that all the time. So what I've done is I created an integral that's a lot simpler. And you go, okay, this is just reversing the power rule. What do I do here? I add 1, so that becomes 6. I multiply by its reciprocal. I have a 1/6 here, but I also have a 1/3 I'm multiplying by. So 1/6 plus c. So 1/3 times 1/6 is 1/18. U to the 6th plus c. But I want my answer in terms of x, so I have 1/18 parenthesis 3x plus 4 to the 6 plus c. So the whole purpose of doing u substitution is to come up with a simple derivative and make it less complicated.
I think I get it.
Okay.
So we take the derivative of what's inside the parentheses and replace, and that will be okay, we find, okay. Tell me where I should go next.
Let me do the next one.
Okay.
So what I'm going to do here is I have parentheses, don't I? So I'm going to let u be x cubed plus 4. So I'm going to have u the fifth right here. And this is going to become, when I take the derivative, can I skip a step, and are you guys okay with this? Are you okay with that? Let me make it a little bigger. I don't know if that got bigger or not. Okay, are we fine with that? So I take a look. I have an x squared here, so I could rewrite it in this form. I have an x squared dx. Oh, Ariana, 6 is 2 times 3. So I'm going to put a 2 here, and I'm going to put a 3 here. And then I've got x to the third plus 5. Now, Owen, some people don't write this step, they kind of do it in their head. So, this is going to be, look at this, 3x squared dx. I can replace this with du. This is u to the fifth. There is a 2. Well, all I do is reverse the power rule. This becomes a 6. This becomes a 1/6. I'm multiplying it by 2. Add my c because it's now worth 2/10 of a point. Simplify this. This becomes 1/3. Get rid of the u and replace it with 3x cubed plus 4 raised to the 6th power plus c. Are we doing okay?
I am not 100% sure of what you do more bombs like that.
Are you understanding my steps?
I think so.
Okay. Let me ask you this. What do you think u will be in number 3?
Me?
Yeah.
Either
It's got to be what's in parentheses. You don't have.
either the square root of x minus 1 or square root of x.
Well, it's the square root of x in parentheses. Is the square root of x in parentheses?
Yes.
I only see these set of parentheses.
There's always a parentheses in the denominator of any fraction.
Yeah, right here is you want to take this, okay? Which is the same as this. Correct?
Mm-hmm.
So I'm going to take this derivative, du is going to be 1/2 x to the minus 1/2 dx, correct? So let me write what I have here. I can rewrite this, x to the 1/2 power minus 1 squared times x to the minus 1/2 dx. Oh, I have this right here, don't I? So I'm going to multiply both sides by 2. Du equals x to the negative 1/2 dx. So I'm going to get rid of this and write 2u. So I'm going to have u, that's gonna replace x to the 1/2 minus 1 to the second power, because it is to the second power, times 2 du. Well, I can bring that 2 out front, u to the third du. So, u, add 1, I get 4. Excuse me, it's squared, sorry. Add 1, I get 3. Multiply by the reciprocal. I got a 2 right here, plus c, so I don't forget about it. So I got 2/3, get rid of the u, replace it with the square root of x plus 1, raise it to the third power, add c.
I think I get it.
Okay. Anytime I have e, taking the antiderivative of e is easy. Would you agree, Ben? Ben, the derivative of e to the x is what?
E to the x.
The antiderivative of e to the x is
E to the x.
plus,
C.
correct, right? It's that smooth, isn't it? So what I'm going to do is I'm going to let u be the exponent of e. So, Ben, what's the derivative of cosine?
Negative sign.
Negative sine of x dx. And if I look what I have here. I have x dx. Excuse me, I have the sine of x dx, don't I? So, I'm going to make this a negative du and write sine of x dx. So I'm going to bring that's just a -1. I'm going to bring it out front. This right here is going to become du, and I got e to the u. I'm going to pause there. Does everybody understand the substitution I did?
Since the fact that negative sign is the derivative of cosine of x,
Correct.
you just change that to a negative.
Right, I divided both sides by that -1. Okay, and you can think of it as that way, as a -1, not any different than when this was 2, and I had to bring out the 2 out front here. See how I have 2 du right here in this problem? I brought out the 2, all I have here is a -1. And so, Ben, what's the antiderivative of e to the u?
E to cosine.
Well, it'll be e to the u plus c, and you're right, it's going to be the cosine of x, correct?
Yeah.
Plus c. You're going further ahead than me, and that's not ever bad.
I also predicted that as well,
Okay.
but I think the way I got it was slightly different, maybe.
Now, Ariana, what's u going to be? What's in parentheses? 3x. Du is going to be 3 dx. Would you agree? And so I'm going to write, I don't have a 3 in here, so I'm going to write 1/3 du is going to replace dx. So now what I have is 1/3 cotangent u du. Well, lo and behold, where's my sheet of paper? I did all those derivatives. Didn't I do the derivative of...
It's sine squared, I believe.
I don't think so. Where did I
It's
just put that?
either sine squared, 1/3 sine squared of x, or 1/3 cosine squared
Right
of x.
here.
Plus c.
Look at this. Here we had f, right? Who did this problem? You did this problem, right? And I asked you to take the derivative of this, right? So this, I'm pointing at the antiderivative, correct? And the derivative we got was cotangent. So this is a derivative. This must be its antiderivative, it's just missing the plus c. Would everybody agree? So, come back here. This is going to be 1/3 the natural log of the absolute value of the sine of u plus c. Well, that means now it's going to be the natural log of the sine of 3x plus c.
I think I get it now.
Okay. Anybody in baseball or softball in here? Nobody? There's a thing in baseball called a curveball. And my guess is it exists in softball too, okay? And so I'm gonna throw a little curveball to you. Maria, what do you think you should be here? X plus 1 is perfect. And do you see where du is equal to dx? Okay. So now I'm going to first write this as x.
I don't see how du is equal to dx.
What's the derivative of x?
1.
So then I multiplied 1 by dx.
Okay, I think I get it now.
Okay? So this is x plus 1 to the negative 1/2 power dx. And now we have this for you. X times u to the negative 1/2 du. Correct? And I said, and it's true, everything has to be in terms of u. And I still have this x here, don't I? Is there a way for me to get x in terms of u? Audrey, you're nodding affirmatively. Tell me where I do that.
Since u equals x plus 1, you can just subtract 1 from both sides.
And say that u minus 1 equals x. So now, very good. So I'm going to have u to the first minus 1, because that's x, times u to the negative 1/2 du. So I'm going to take u to the negative 1/2 and times u the first. Grace, what does that give me? The bases are the same. What do I do with the exponents? In other words, what's u the first times u the negative 1/2? Not sure? U the 1/2. 1 plus a negative half is u the 1/2. So this is going to be u the 1/2 minus u to the negative 1/2, because that's a multiplying 1 together, du. So now I just have to add 1. That gives me 3/2, 2/3, minus, I'm going to add 1. I'm going to have 1/2 multiplied by the reciprocal, 2 plus c. So my final answer is 2/3 parentheses x plus 1 to the 3/2 minus 2 x plus 1 to the 1/2 plus c.
I think I get it. I'm not 100% sure if I do. Let me see if I can help head one of these problems. Oh, did we finish 6, or did we find what x is? Did we solve for x yet, or no?
For which one?
6. Did we complete number 6?
Yeah, this is right here.
Okay. So for number 7, parentheses would be 1 minus 4x squared.
That's how I would start. So du would be what?
Du would be negative 8x
Okay.
dx.
So I need an x here. Do I have an x there?
No.
No. Hoop. Can't do. So I'm gonna rewrite this. I'm thinking it is sine inverse. Because that's the form of sine inverse. So in other words, I'm going to let u be 2x. So du is going to be 2 dx, which means I'm going to have 1/2 du equals dx. So this is going to become 1/2 1 square root 1 minus u squared du. So I'm going to have 1/2 sine inverse of u plus c. But what is u? U is 2x plus c.
I'm just trying to write everything down.
Yep. I went really fast, I'm sorry.
I'm starting to think I get it.
That's a hard one, because you don't see that, but you could see that, hey, I need to have an x in here floating somewhere. Okay? Back side. All right, now, Maria, these are definite integrals because there's numbers there, right? So, LIU is going to be what?
2 to the 3rd plus 1.
Callan, DU is equal to what?
3t squared.
D squared dt, right? I don't have any x's in there, all right? And I see a t squared, don't I? So I have a t squared dt. And I have a t squared dt, except I gotta write it this way. 1/3.
Yeah, we put a 1/3 on the outside.
Yep. T squared dt. And Matthew, you're right. There's gonna be a 1/3. T squared dt is du, and this is going to be u, and I'm going to write it to the 1/2 power.
We do that due to the square root.
Correct.
And then we, I believe, we place stuff back in, or no?
Not yet. Okay?
We plug the
Everything up here is in terms of what letter? Everything right here. What's my variable up here? T. Everything's in terms of t. This is a dt, that's a t, this is a t squared. 0 and 2 are t's. This is t equals 0, this is t equals 2. Well, now I'm down here in u. I can't use t's. The t's got to be gone. So I'm going to convert those to u's. How do I do that? Well, I know u is equal to t cubed plus 1. Well, one of my numbers here is 0. So I'm going to take 0 cubed plus 1. And so instead of 0 here, I'm going to have the number 1. That's the u value when t is 0. I'll say it again. This is the u value when t is 0. When t is 2, I'm going to have 2 cubed plus 1.
Or 9.
How about squared? No. Yeah, cubed. Or 9. Correct. And so now I'm going to figure out the antiderivative. I'm going to have u to the 3/2 I'm going to have 2/3 here. I already got this 1/3 here. It's a definite integral, so I don't need any c. I'm going to write a 1 and a 9 here. And so now I have 2/9 u to the 3/2 evaluated from 1 to 9. So I'm going to have 2/9 times 9 to the 3/2 minus 2/9 times 1 to the 3/2. Here's my b, here's my a. We just talked about this.
I'm pretty sure I'm starting to get it.
Okay, so what? 9 to the square root of 9 is what? Square root of 9 is?
3.
3 cubed is?
3 cubed is 27.
So I have 2/9 times 27 over 1. Minus, what is 1 to the 3/2? 1 to any power is what? 1. So I just have minus 2/9. So this is 54/9. Take away 2/9, and I get 52/9.
I'm pretty sure I'm getting it now.
Colin, what's u gonna be?
Sine of x.
Perfect, sine of x. What's du?
Cosine of x.
Cosine of x dx, correct?
Yes.
Notice, Colin, here's a cosine, here's a dx. In my heart, I am a happy camper. Okay, so leave those alone. This is going to be replaced with du, and I get u to the 1/2. Why? Like Matthew said prior, I'm just replacing the square root with a number in which I'm going to add 1 and then multiply by the reciprocal. Now, I got to make sure u is equal to sine of 0. Calvin, what's the sign of 0?
1.
Try again.
0.
Oh, 0.
0. So this will stay 0. What's the u is equal to sine of pi over 2. What's pi over 2? 1. 1. And to be honest with you, I like this. So, u to the 3/2, 2/3, evaluated from 0 to 1. When I put 1 in here, raise it to the 3/2, it stays 1. Multiply it by 2/3, I get 2/3. Minus, when I put 0 in here, BAM! Everything is gone. And I get 2/3 is my answer.
Yeah, I'm